I'm going to establish the identity for problem number 13. I'll start by looking at the equation to decide which side's more complicated. In this particular problem, the left-hand side is more complicated. So I'm going to start by circling that side of the equation. Now I'm going to look for any obvious substitutions from my three Pythagorean identities. Recall, these are the three Pythagorean identities. They all have trig functions squared in them or squared numbers. One is a squared number. I'm looking for any squares in the problem. There aren't any, so therefore I'm not using any of my Pythagorean identities. So now I'm going to look for is any reciprocal substitutions or quotient substitutions. I'm going to leave behind all sine cosines unless necessary to switch them out and exchange all cosecants, secants, and tangents and cotangents. So in this problem, I see a cosecant and I know that I can substitute that for 1 over sine of x. Then I see a 1 over secant and I know that I can substitute that for 1 over cosine of x. Since they're being multiplied, I'm just going to make this one big giant fraction and make it 1 over sine of x cosine of x. Then I have minus, I can change tangent to sine of x over cosine of x. Now, this 1 over sine x cosine x, I could have left it as two separate fractions and then multiplied them, but I figured it'd be easier just to make it one fraction at once. The next thing I'm going to do is I'm going to realize that I have two different terms that need to be subtracted, and if you look on the right-hand side, I only have one term. So now I know I have to subtract them. In order to subtract them, I need a common denominator. So I'm going to look and see my common denominator is a sine cosine, just like my first fraction. So my first fraction I'm going to leave how it is, and my second fraction I'm going to multiply by sine of x over sine of x. Now I can make this one big giant fraction. I want to do that, otherwise I'm going to start simplifying when I don't really want to yet. All right, so my common denominator is sine cosine. And now I'm going to write down what I have in my numerator. I have a 1 right here, then I have the minus sign, and then I have sine times sine, which is sine squared of x. Now the reason I'm circling things in my numerator is so that you guys can see them. That's not part of something that you should be doing when you're actually writing this on your test or quiz. All right, the next thing I see is I have a 1 minus sine squared of x. That looks familiar to me. If I go back to my Pythagorean identities, my first trig identity has a 1 and a sine squared in it. So I want to manipulate this so it's 1 minus sine squared of x. In order to do that, I would have to subtract sine squared of x from both sides, and I'd be left with cosine squared on this side. So I know that I can substitute 1 sine squared of x for cosine squared. That's what I'm going to do next. I'll replace this 1 sine squared of x with cosine squared of x. So now I have cosine squared of x over sine of x times cosine of x. All right, if I'm stuck right now, I can look at what I'm trying to get. I'm trying to get cotangent, which is cosine over sine. If you notice, I have a cosine in my numerator. I actually have 2 of them, and I have a sine in my denominator. So it's there. I just have to get rid of the cosine in my numerator and the cosine in my denominator. So if you want to write it out as 2 separate cosines, you can. Like so. And then you can simplify the cosine over the cosine. I'm left with cosine over sine, which is the same thing as cotangent. So now I have cotangent of x equals cotangent of x, and my trig identity has been established. Or sorry, I established my identity. If I look back, also, I could have skipped this step right here, and I could have said, I'm going to cancel out a cosine with one of these cosines. I have cosine over sine. That is also allowed.